If every single commercial pilot on Earth is operating inside a globe, why do the navigation charts spread across their cockpit display a completely flat surface, with straight grid lines and no curvature correction whatsoever? Not a globe projection, not a spherical reference system, a flat grid, oriented to a flat horizon, used to guide metal tubes carrying hundreds of people across thousands of miles. And here's the thing, those charts work perfectly. Every flight, every time. So who exactly is flying the globe? Aviation navigation uses something called Jeppesen charts, the industry standard route maps used by commercial pilots worldwide. These charts are drawn on flat projections. Distances are calculated using flat plane trigonometry for short and medium haul routes. Altitude references use a flat datum baseline. So pilots talk about flying at flight level 350, meaning 35,000 feet above a flat reference plane, not 35,000 feet above a curved surface that changes shape depending on your latitude. The language, the tools, and the calculation methods all treat the operating surface as flat, because in practice they produce accurate, reliable results when used that way. Now let's think about flight routes in the Southern Hemisphere for a moment. When you look at how these routes are planned, you might notice something a bit odd compared to what you'd expect from a globe. The paths sometimes seem longer or take unexpected turns, and, well, that's raised a few eyebrows among those who pay close attention to flight planning. And here's where the fuel question becomes genuinely hard to dismiss. Plot a long-haul route on a globe, say from Santiago in Chile to Sydney in Australia. On a globe map, the logical route appears to curve dramatically northward, passing near or over Antarctica to reach the shortest geometric path between the two cities. But, actual flight paths on that route don't behave that way on globe projections. When you map real Southern Hemisphere flight paths onto a globe, the routes look curved and inefficient, burning more fuel than the direct path should require. Plot those exact same routes on a flat plane map, specifically the azimuthal equidistant projection centered on the North Pole, the same projection on the United Nations logo, and the routes become straight lines, direct, logical, fuel efficient. The flight paths make sense on one map and look irrational on the other. On a flat Earth model, every long-haul flight route traces a straight line across the flat surface because, well, the surface is flat, and the shortest path between 2 points is a straight line. Fuel consumption aligns with distance, because the distance is calculated correctly on a flat reference. So when you look at how these routes are planned and the